So you want to work on radios. That's the big hold up for a lot of people is, God, where do I start? Well, honestly, read. And if today you can get your education in electronics for free online. Now you're going to need test equipment, but you don't have to have a huge, vast amount of stuff. But it can be, how do I want to put this? Frustrating, until you get a few repairs under your belt. The best thing I can tell you is don't give up. Just, keep at it and it will get easier. Trust me, as long as you have any, electrical aptitude, if you were meant to do this, you'll pick it up. Like I say, the first couple of repairs, you do anything is going to be frustrating. I run into stuff myself still that just makes you want to pull your hair out, sit there and scratch your head. But everybody has to start somewhere. So I think I'll start doing some actual videos on repairs and whatnot, actual troubleshooting, my procedure, and how I actually went to finding the problem. So here's a perfect example. Here's a GE. This is a 3-5825A. Now, they made this radio in two versions, the A version, which this is, and the B version. The difference there is the B version was basically the super bass, the GE super bass, in a mobile radio. So I call it the super mobile. So it has the dual stacked circuit boards. It's a little bit thicker, it's a little bit narrower, but a little bit thicker and nowhere close to as deep. This radio is a lot deeper. Because as you can see, this is a single. Actually, it's kind of depending on what radio you'd get this board in, but in my opinion, just as good. There's they're both really good radios. The big difference is, like I say, is the other one is a dual circuit board, which it's kind of more of a pain in the butt to work on. So actually, as far as repair work goes, this one's a lot easier. So what's wrong with this one? So this is my radio. I got it cheap. It doesn't work. It does not transmit. It does not receive. Turn the volume up. There's nothing. Key the microphone. Nothing. Actually, it just worked there for a second. Okay. Now it's dead again. I can tell you right now what the problem is. It's the CBPA switch. And it was sold as not working, no transmit, no receive. It needs a CBPA switch. Now, how did I go about finding that? So when I powered it up, basically to right here, that's what I did. Keyed the microphone, nothing happened. Turn the volume up, absolutely dead. There's no sound. So the first thing I want to do, because the radio is not going to do anything if it doesn't have if the oscillator circuits aren't working. So the first thing I do, and you really honestly don't even need the service manual if you've got an oscilloscope. These radios have test points, so just go through it, all the test points in here, and check them with your scope and see if you actually have a signal. This camera is going to get in my way. It's one of the main reasons I don't do this kind of video, because it's so hard trying to get camera, and it just gets in the way for me. But so in these radios, you'll see these terminals sticking up. Like right there's one, right there's one, there's one here, and there's one shoved down in there. So, we're going to be looking at that oscilloscope right there. And I can go down and, hook up to these. Yeah, I can see a little bit of static noise, but that's just it picking up noise, line noise and whatnot. So there's nothing there. Like I said, you really don't even need a service manual to check that. You can assume that at least at a bare minimum, 1, if not 2, 3, or 4 of test points that you see around the PLL or the synthesizer area, they're going to have a signal there. One's probably going to be like 10.240. Another one's going to be, you can look at your crystals a lot of times. And that's another thing. Actually just take your scope probe on the bottom side of the radio and attach it to the crystal. Is the crystal oscillating? If you hook up your scope to the crystal and it's not doing anything, it's not working. So the oscillator circuit's not working. So we've checked it up on the top here. I know it's not working. So let me unhook the microphone here. So if we look at the bottom side, I know that these two terminals here are the 10.240 crystal. So right on the top side of the board, that's the 10.240 crystal. Doesn't matter what mode I'm in, that thing should always be putting out 10.240 megahertz. So I hook up to that crystal to either side, and it's completely dead. So yes, we do have a problem. And same thing at the PLL, even if you don't have the schematic, you can just go through with your scope probe and check. If you check at every single pin on the PLL down here, and there's absolutely no signal on any pin, you know you've got some serious problems. So now we know that all of the oscillators are dead in this radio. Absolutely nothing is working. So what's the next thing to do? Now you need the schematic. Actually, let me unplug that. Makes it easier for me to flip the radio around. So now's the time to dust off your service manual. So you want to look at the schematic and find out, well, what makes the oscillator circuit work in this radio? So we can see here, here's the 10.240 crystal, and here's the oscillator. So it's transistor Q6, and you can see we should have 0.45, and minimum we should have somewhere around 0.45 and 1.67 volts. Now one of them is not going to have any voltage because it goes to ground. So if you locate that transistor in the radio, and where that is, the crystals, that little red thing you can see there, they're marked with marker. There's red, green, and blue. But that red one down there, that's the 10.240 crystal. Q6 is right to the left of that. So that is, let me get a pointer here. A big meat paw out of the way. So that's this pin, and this pin. That's the three legs of that transistor. So if we just take a voltmeter, now I have the ground attached to my distribution point. So for power right here, this is the cord going to the radio, and I just have the negative lead. That way I don't have to keep hooking up the probe down here at the radio. It's one of the reasons I like this. I can just hook up my ground up here. I don't have to worry about finding a good ground connection inside the radio. But now if we take I'll actually hold the radio up here. So if we check at those three terminals, we should have voltage on at least three of them. And as you can see, we really don't have anything. The 0.01213, anything like that, yeah, that's really non-existent voltage. So we don't have any voltage. So we seem to be having power supply problems. If it was a bad transistor, we would still have some voltages there. So where does this transistor pick up voltage? Well, we look down here, we can see at 0.6, we should have 5.35 volts. So that's going to be at the main. You'll see these, and if you're familiar with SAM schematics, they'll have points. You'll see them all over the schematic. 7, 5, 9. They're all over the place. And they'll have a voltage measurement underneath of them. These are all from the power supply circuitry, the main power supply circuitry where it branches off through the radio. To cut down on having to have 500,000 interconnecting traces running throughout the schematic, they just know that whenever all of these circuits that hook up here, they'll just mark them as a 6. Makes the schematics easier, and it also makes looking at the power supply circuit a lot easier, because here is the entire power supply circuitry, basically, for the entire radio on this one page right here. So you can see we run from number 1 down to number 17. These are all different power supply taps. And what we were looking for, we flipped the page here, we were looking for tap number 6, because we don't have any voltage here. Now I could check it, maybe one of these, either this resistor or this resistor could be bad. Yeah, it's kind of doubtful. Anything's possible, but I usually, if I don't have voltage here, I'm going to go straight to the source next. I'm not going to go through and check each and every individual component. Now you can do that, but I'm doing this for a living, so it can be time consuming. I'll just go to the next major component, and that's going to be, in this case, it's going to be the next major circuit or component is going to be the power supply. So I'll just jump straight to there. So we're looking for power supply circuit number 6. So if we come back to the power supply circuit here, we can see here's number 6. That's the 5.35 volt source. And you can follow that back across. There's an 82 ohm resistor here. Again, I'm just going to skip resistors, checking at each one of these points. I want to come straight back to whatever supplies the voltage for basically the, before it branches off. And that's the voltage regulator right here. which is Q44, a 2SC1398P. So we should basically have our line voltage here, because it comes through the power cord, comes down through the CBPA switch, right there, comes down to this transistor. So we should have 13.72 volts. And here's the regulator circuit. It's a Zener diode controlled transistor, and we should have around 9.68 volts at the emitter here. And that's what feeds all of these branch circuits then. So we want to check to see what our voltage is here at this transistor. Now in this radio, that transistor is located right here, has a heat sink on it. Okay. So on the underside of the radio, again, let me go up here, get my test lead out. We can come down and see at least one of those we should have 9 volts, and the other one we should have at least 13 volts. And you can see on all of them we have nothing. So there's no power there. So the next major component, you're going to, again, just backtrack some more. And what's that come to? The CBPA switch. So that's going to be common failure points in anything. It's mechanical and it's a switch. Now in this radio, this thing has had a lot of work done to it. It's got channel modifications, which all of this shit's going to get removed, because this is my radio. But it's got a channel mod. I'll be taking that out. All this wire, resistors, all this crap's going to go in a trash can. I don't need extra channels in this radio. I want it back to factory. But like I say, what I did next was looked at the schematic, checked the CBPA switch, and it calls for the orange wire, and that's where it actually comes down, this orange wire here, down to this test point right here, and that's when I had it hooked up with a voltmeter, and that's the main supply that is supplying the main power to that transistor. And you can see when I move the CBPA switch, ta-da, we have voltage. I let go of it, it goes away. And it's there a little bit, so yeah, it's a crapped out switch. I may try cleaning it, but you can see, if there's a little bit of voltage. If I hold it up though, right there, oh, somewhere in there, there we go. We've got voltage. Trying to do this with, and of course the microphone's unplugged now. And that's another thing. You can hear there's a noise. There's static in the speaker, so something's happening. Something's making that static noise. Well, that's all the PLLs and oscillator circuits starting to work and going away. So you can see we have voltage there now, and if I key the mic, and of course I disconnected the coax cable from the radio. Split second. Keying without an antenna or dummy load on is not going to kill it for doing it for 1 second. Okay, so get the switch back to where we're getting voltage again, and you can see it works. And if I let go of the switch, nothing. And I don't think it's dirty. I think the contacts are actually bad, because I actually did sit here and do this for quite a while, and it's not reliable. Sometimes it'll work, sometimes it won't. Yeah. Usually if it's just dirty, you see it's working now. Yeah, not working again. So usually if you flip the switch back and forth several times, if it's just dirty contacts, usually that'll be enough to clean it. You just go like that several times, that'll clean it up. This one apparently it seems to be, yeah, it's just a bad switch. So I'll have to, now I've got some of these switches pulled out of cheaper, just the old AM radios. A lot of these switches are the same, so I can pull a good working switch out of another radio. But that's the process. It's a lot of times I try and tell people, don't make it more complicated than it is. Try and keep your troubleshooting in large areas, or large pieces of a circuit, or entire parts of a circuit. So if you know you're having a problem, don't get discouraged by all of this. There's, pages and pages of schematic. What, 1, 2, 3, 4, 5, 6, 7. There's 7 pages worth of schematic to this thing. Can be very intimidating to look at. Like I say, the first thing to check, see if you've got voltages. Well, if we'd have checked also with the PLL chip, there's a number 6. We'd have found that the PLL chip also had no voltage. We would have checked at the VCO block and found that also connects to number 6. That would have had no voltage. Actually, almost none of the radio, a little bit did. As you can see, it's on, but most, there's only a few circuits, 1, 2, 3, and 4, that feed off before this voltage regulator. Everything that feeds off taps 5 through 17, all the way down here, all are controlled by this voltage regulator. And or actually 3 and 4 also, they're before the switch. So there's only 2 taps, 1 and 2, that are before the CBPA switch here. Or actually, no, not even that, because that's the PA. There's only one, number 1. So there's only 1 tap that feeds right off of the on-off switch. Everything else, as far as the CB is concerned, is after the CBPA switch. So that killed the entire radio. Absolutely nothing's going to work other than basically the channel indicator came on and a few other circuits. But like I say, when you're troubleshooting stuff, doesn't necessarily need to be like this. It could have been just an oscillator problem, but the principle would have been the same. You could have come in and found that, like I say, crystals, you can just stick your scope probe on either side of the crystal. Usually the signal will be a lot bigger on one side than the other. But just check. I do a lot of troubleshooting without a schematic. I'll just look at a radio, go, okay, it's dead. First thing I'll do is take a scope probe. I'll check at the crystals. No signal. Or if I have this, if this oscillator circuit's working, but maybe this oscillator circuit down here is not working. It's just a process of elimination, and as you work on radios, you'll find, you'll get your own rhythm down to doing stuff. The thing is trying to do it, in my case, because I'm doing this for a living, I have to be expedient at it. I can't spend days and weeks troubleshooting one radio. No customer is going to want to pay for that. Another thing is, when you're looking at stuff like this, use the alignment procedure. I know I've said that before, but a lot of people seem to forget that. Because when you go through an alignment, well, actually, if you see all these test points here, TP1, TP2, let's see, there should be one more at least here. Where in the hell is it? I think there's one more in this area. I guess that is it actually on this part. Yeah, right there. Okay. I was going to say I was missing something. That's the big VCO buffer. There's TP13. But go through the schematic. When you look at the alignment procedure, it's going to be telling you, matter of fact, we can just flip to it. The first thing you're going to do in most alignments is going to be the synthesizer circuit. So it's going to tell you where to connect, input a frequency counter to TP2. You're going to adjust for 10.240. You don't have to really hook up a frequency counter. You can just be using your oscilloscope. But hook up. Do you have 10.240 there? When you hook up the pin 4 on IC2, do you see a signal there? So you can just go through the alignment procedure and use it as a troubleshooting tool as well. Check at those test points. Those are major points. Usually that's going to be your signal outputs from the the entire previous circuit, either an oscillator or the PLL chip itself. So check at those test points and see if you have a signal. If you get to a point like TP3 and you don't have the 20.105 or 20.1035 signal there, well then you have. Just look at the circuit before TB3. What's feeding TP3? And, back trace till you find the problem. And like I say, when you're troubleshooting, you don't necessarily have to check every single component. If you're having a problem, you don't have a signal here, you don't have to check every individual component. Like I checked the transistor here. I saw I didn't have any voltages. I didn't waste my time checking for voltage across this resistor, go back, back to the next page in the power supply circuit, check to see if I had voltage on either side of this resistor. I just go straight to the source. Go back to the next most major, block of circuitry, which in the case of this was the power supply voltage regulator circuit. I checked there and had no voltages on any pins. The only other thing it could be, because the radio does turn on, the channel indicator comes on, and the lights and whatnot. the next most major component that separates this voltage regulator from that power socket on the back of the radio that you're supplying it is the CBPA switch. So, don't be afraid to tinker with radios, especially it's already broke. What are you going to do? Break it again? You've already got a non-functioning radio. Now, you might not want to take something as advanced as a sideband radio to start with. Go on eBay, flea markets, ham fest, flea markets, whatnot. There's just sources all over the place where you can get broken radios. eBay's a great place because, trust me, there's shitloads of broken radios on eBay. And a lot of times you can get a box lot of 5, 10, 15, maybe even 20 radios on the cheap. The shipping will cost you 2, 3, 5, 10 times more than the actual radios themselves. And you can get a bunch of broken radios. But I'd suggest if you have no experience doing troubleshooting, start out with simple radios. Simple little AM radios only, a little smaller, because the smaller as the radio get, usually the cheaper they are, the less components they have. They're very basic. Start out with some of the basic radios. Once you can troubleshoot those, it's basically you can get your feet wet with those. Work your way up in the in radios, and you can work your way up because once you get to this class of radio, the GE Supermobiles, stuff like this, they don't get much more complicated than this other than a few very rare radios like some of the CPI, Stoner, radios like that. But yeah, this is about as advanced as a CB gets in, as far as complexity, because these were the top of the line radios. So, take it in small steps. Don't expect to, become an experienced repair tech overnight. But by the same token, don't be afraid to try. We all had to start somewhere. Most people start with a voltmeter. Honestly, that's all you would have needed for this. You could have diagnosed this with nothing more than a voltmeter. Because, now I went to the oscillators themselves. I didn't necessarily have to do that. I could have gone to the PLL chip. And if I had nothing more than just a little handheld digital multimeter, and hell, it could have been a little pocket one, those little cheapy $5.99 ones. You could have troubleshot this radio with a test light. I don't suggest using test lights, and I shouldn't have said that. It's not going to hurt this radio, but in some circuits, a test light can damage a circuit because the light bulb draws too much power. But like I say, you really don't need anything more than a voltmeter to diagnose the problem that this radio was having. You would have, run across the pins of the PLL and found there was no voltage. And it would just, you'd need the schematic, but you would have back traced it to this transistor, the voltage regulator. You'd have seen that there was no voltage there. And then the next thing in line, followed this orange wire up, that's the CBPA switch. So it doesn't take a lot of advanced equipment. Now, it takes a lot of advanced equipment to do an alignment properly, but a lot of times, troubleshooting, you don't really need a lot. Voltmeter at a bare minimum. Oscilloscope is going to be your next thing to get, probably. It doesn't have to be a super high-speed one, and you can pick up cheap ones on eBay nowadays. They don't run extreme amounts of money. A scope, next thing you're probably going to want would be a frequency counter. Because a frequency counter, you have to have a frequency counter to be able, especially when if you plan on doing alignments, you need to be able to properly calibrate the radio, the oscillator circuits in here. And to make adjustments, you have to have a frequency counter to take frequency measurements. And the next thing you would need, if you're going to get into actually working on radios, you're going to have a signal generator because you have to be able to put signals into this radio. Again, they can be as basic or complex as you want to get into radios. You don't have to have the multi-tens of thousands of dollars. That's what those types of pieces of equipment like that cost when they were new. You don't have to have stuff like that. They cost so much because that thing does so much. It's got all kinds of features. They're AM, FM, sideband. It's got it can handle decoders. Takes all different kinds of measurements, adjacent channel power. I mean, it just harmonic measurements. You can just do a phenomenal amount of work with that thing. But you don't need all those fancy features to do basic troubleshooting, and repairs. Start with the basics and work your way up. So, I hope some of the little tips and suggestions, might help somebody out that's, kind of borderline thinking about, well, maybe I want to work on my own radios or not. Do it. Give it a try. What's the worst that's going to happen? You won't be able to fix it. If you get one that you really want to fix and you've tried and you can't fix it yourself, then send it to somebody to work on. Doesn't have to be me. Find somebody or a shop somewhere that can, do it for you. But don't be afraid to try. Like I say, the biggest thing is education, and you can get that online nowadays. You can download, electronics courses. There's a lot of stuff online nowadays. Just do a Google search. The Google monster can find you all the information you'd ever want to know. And you don't actually have a lot of cases. You don't have to have. Now I have the complete set of SAMs, but you don't have to have those. In most cases nowadays, because of the internet, all the schematics and service manuals for most radios, not all of them, there's still some out there that haven't been published online, but for the majority of cases, most radios, the service manuals and schematics can be found online. So don't let that hold you up. Just do a little bit of searching. Sometimes they may be hard to track down if they're rare and oddball radios, but for the majority of your basic radios, they're going to be fairly easy to find. Another thing to remember is a lot of these radios use the circuit boards or the chassis, and when I say the chassis, I'm talking about the actual board with all the components on it. That would be used, could be in a couple to dozens of different radios. This radio is no exception. This was a very popular chassis. It was used in a shitload of other radios. So, if you can't find a schematic for, say, the specific radio you're working on, well, you might be able to find a schematic and service manual for that chassis in a different radio. So, there's, like I say, just a few tips. I think I'll start doing, I'll try and start off with some easy radios like this, troubleshooting, the actual procedure of going through and finding problems, some of the basic steps, and slowly, as time goes on, I'll try and, I guess you could say pick up the pace or the complexity of repairs, or actually the troubleshooting. The repairs, that's the easy part. Changing the part once you find it's bad. But it's the complexity of, troubleshooting sometimes, especially when you get into synthesizer circuits. And these radios are a good example because these have these sealed cans that are potted in epoxy. And I've done videos on how to rebuild those. But, yeah, those can be a stumbling block for a lot of people. But, like I say, I'll try and get some that are fairly simple and straightforward. Try and go through the troubleshooting procedure, exactly what I did, where I tested, and like I did with this one. That was my exact procedure when I got this radio. Hooked it up, keyed the mic, didn't do anything, flipped it over to an antenna, had no volume. Okay, the first thing I normally do is I'm going to check to see if I have any frequency synthesis going on inside the radio. Check that the crystal's dead. Check the transistor, no voltage. Why don't I have any voltage? Go back to the voltage regulator, no voltage. Followed back from that to the CVPA switch, ta-da, there was my problem. Simple as that. It took me a minute and a half maybe, and I had this radio diagnosed. Now fixing it, yeah, that's a little bit, because you got to take all the knobs off, take the faceplate off to be able to get in here. It's going to take me 10 times longer to repair this radio than it did to troubleshoot it. But, this is mine, so I can now just select, because I've got to undo all these modifications out of this thing. So in my case, I'll just put it back together, put a Post-it note on top of it, that, how much I paid for it, and, that it's been diagnosed and it needs a CBPA switch, and that's all that's wrong with it. But, and then I'll, hopefully before I die, I'll get time to actually maybe, restore it and fix it up. But there you go. So in the future, keep an eye out for more repair videos.